What's up, people? Welcome to the session. How are you guys doing? I hope all of you guys are doing good, chilling out at your homes and taking care of yourself at the same time. Welcome. My name is Anup, and this is Vedantu 9th and 10th English channel. If you haven't subscribed to the channel yet, please make sure that you do, because today, people, is the day that we are going to be doing something amazing. And yes, the session for today is, guys, about electricity, and this is for class 10th CBSE. Now, what is the purpose of this one shot session is that, guys, what we've done so far is we have completed the entire chapter of electricity, right? I hope you guys have already seen that. If you haven't seen that yet, make sure that go to the description. You'll find the entire link. The playlist will be there. Make sure that you check those out. If you have any doubts after that, let me know in the comment section, or you can also reach out to me personally. I've given my personal email ID at the end of every session, so you can check that out as well. So today, what is the purpose? Then, yeah, we've already completed this. Then why are we here, sir? Let me answer that question. What we're going to do today is we're going to revise the entire chapter in a brief manner, and we'll also be solving some questions pertaining to that. All right. So today is going to be an amazing session. And let me tell you that upfront, because today we're going to be doing a lot of amazing problems. So make sure that you have pens and papers with you, because it's going to be super duper important that you try those questions out and let me know in the chat box, in the comment section, or in my personal email ID that which of these questions were you finding it the hardest, and which of these do you think you would need more practice in. All right. I hope you guys do that. So that's it, people. Let's get into the topic, electricity in one shot. But before we get into that, guys, let's start our day with a small dose of positivity, right? Because it's hard to stay at home 24/7, and I know that you guys are getting cooked up on the inside, having no one to talk to, and it's hard to talk to your parents also sometimes about how you feel. So let's forget that for the next couple of minutes, and start our day with a little bit of positivity, right? The quote for today, unfortunately, is not a quote. It is actually something that is all about action. See, guys, again, the pandemic has been very hard for all of us, for you guys, for us, for everyone around you, your parents, everyone, your cousins, your sisters, brothers, everyone. So we at Vedantu understand that, and we have pledged 15 crore rupees to help about 12,000 students around the country. Yes, guys, 15 crore rupees to help our friends, your colleagues, your batchmates, maybe not in the same school, but yes, the people of your age who are suffering because of the pandemic. I mean, what could be more motivating and aspiring than that, right? And if you want to be a part of it, if you want to contribute money, if you have a little bit of pocket money, even if it's 10 rupees or 20 rupees, that's perfectly fine. If you don't have money, that's okay. You want to help in some way or another, go to www.helpindialearn.in. It's not like you're going to Vedantu website. No, this is an initiative by Vedantu. All you have to do is go to www.helpindialearn.in initiative, and you can do whatever contribution you can from your side, be it money, be it volunteering, whatever it is. What is more greater than helping another person? There's no greater feeling than that. All right. So I hope you guys do it. With that positive note, guys, let's get into the topic for today. So the last session that we did was based on electric power and energy. If you haven't seen that video yet, make sure that you watch that out, because that is an amazing session where we did a lot of amazing numericals. So make sure that you check that out. So this is the entire overview of the session, people, the chapters that we did. Electricity, we talked about electric current, electric potential, what is electric potential difference, Ohm's law, resistance in series and parallel, heating effect of electric current, and electric power and energy. That was almost one breath. In one breath. Clap, people, clap. Talent. Anyways, so guys, let's get started with today's session, people, without wasting any more of our valuable time. Now, guys, the first thing I want you guys to do is very simple. Press Control Print Screen, or just print screen. Take a screenshot of this one, or download the notes at the end of the session. It will be given in the description. But this, my friends, is the entire chapter's overview, a mind map of the entire chapter. For all those who are, very confused about organizing your thoughts, this is the way to do it. A simple mind map A single picture that tells the entire chapter's overview, all the important formulas, every single thing that you need is right here. So electricity, what all did we see? We talked about electric current, what is electric potential, what is an electric circuit, what are the factors affecting resistance. We talked about what are the dangers of mishandling an electric appliance, resistivity, Joule's law of heating, symbols and components for drawing different kinds of electric circuits. We talked about power, resistance, all of that. Take a screenshot. I'll give you 5 seconds, or pause the video and take a screenshot. Let's move ahead and understand about each and every one of these topics briefly. So yes, people, let's begin now. Listen up carefully. The first thing that you learned in this chapter is what is current. Even though current is a very common term that is used, current came, current went, current will come at 5 o'clock. It's a very common terminology that is used. But in terms of physics, what is current? We have learned that current is nothing but the rate of flow of charge. So here's the thing, guys. When you talk about when electrons are flowing from one end to the other, that is what is producing the current. So when you talk about those charges with respect to time, that is what is called as current, the rate of flow of charges, because the electrons are the ones that is responsible for producing this current, and when they are flowing and you're with respect to time, when you check it out, that is what is called as current. So mathematically, people, when you express current is expressed as current is equal to charge divided by time taken, because it is nothing but rate of flow of charge with respect to time. Rate of change of velocity is acceleration. So yeah, in the same way here also, with respect to time when charges are flowing, that is what is called as current. So the SI unit then becomes what? The SI unit of current is nothing but, the SI unit of charge is nothing but coulomb, and the SI unit of time is nothing but seconds. So coulomb per second is the SI unit of current, or it can also be written as amperes. Simple. This is the basic first topic that you must understand, remember, and apply in the examinations, in your everyday studying when you're going through this particular chapter. All right, now that you've understood this, guys, this is a very common question, that define what is 1 ampere. A very common question, has been asked several times in the board exam as well. So let me tell you how to do that, people. So I just told you that current is nothing but what? Rate of flow of charge, and the SI unit of current is nothing but amperes, or we can write it as coulomb per second, and the SI unit of charge is coulombs, and the SI unit of time is nothing but seconds. So if I were to just put 1 in front of all the 3, in front of A, in front of C, and in front of S, what will it become? Just read it out in your English, in your words, in your own words in English. Just expand the same. The current is said to be 1 ampere when 1 coulomb of charge flows in 1 second time. That's all. Easy 1 mark. That's all, people. So how do you define it? Once again, just put 1. No matter which kind of question they ask, define 1 volt or define 1 ampere. Just do the exact same thing, where you put 1 in front of all the variables that you have, all the variables that you have, all the units that you have given. Just put down the value of 1 in front of all the units and explain in your own words. You don't have to write the exact same words also. Explain in your own words in simple English. That's all. All right. So 1 ampere is the current which flows in a conductor when 1 charge passes in 1 second time. That's all. All right, guys. Yeah. Unfortunately, it is raining right now. I hope the power doesn't go off. Anyways, if it does, remember, I'm Batman. All right. So anyways, let's get back to the topic. So here's the thing, guys. What causes the current to flow? What causes the charge to flow? And the answer to that question is potential difference. So what is potential difference? See, guys, potential difference is nothing but the work done to move a unit positive charge or a unit test charge from infinity to a particular point. That is what is potential or electric potential. Potential difference is nothing but the work done to move a unit test charge or unit positive charge from one point to the other. Now guys, for all those who are confused about this topic about current and potential difference, my advice is very simple. Go to the first session of electricity. Trust me, everything would be muck and clear. Make sure that you do that. All right. Trust me, I've explained the entire concept in such a deep manner. You would definitely understand it. So make sure you check that out, right? So yes, people, that is what is electric potential and potential difference. Electric potential is what? The work done to move a unit positive charge from infinity to a point. And potential difference is the work done to move a unit positive charge from one point to the other. So how do you write that mathematically when you write it in terms of a formula? The potential difference is nothing but work done by charge, because it is the work done on a unit charge. So it's work done by charge. So the SI unit of potential difference is nothing but what? Joules per coulomb, because the SI unit of work is joules. SI unit of charge is nothing but coulomb. So joules per coulomb, which is also written as volt, named after a scientist called as Alexander Volta. So in order to honor him, we have named joules per coulomb as volt. Now I would suggest you to remember both these guys. Don't just remember as volt alone, potential difference is volt. No, sometimes they might ask you which unit, which quantity has the SI unit as joules per coulomb. At that time, you'll not be able to figure it out. So remember both of it, joules per coulomb, which is also written as volt. Now again, here also a very common question that has been repeated time and again is, how do you define 1 volt? Again, just put 1 in front of that volt, 1 in front of the joule, and 1 in front of the coulomb. So what will you get? The potential difference is said to be 1 volt when 1 joule of work is done to move a unit charge or 1 coulomb of charge from one point to another. That's how easy was that, right? Like bacha, all of this, like bacha, you don't even need me for all this, but still. Anyways, guys, so people, now here's the thing. Like I told you guys, at the end of every question, at the end of every topic, we'll be doing one question as well. So it's very important that you have your notebooks and pen. So pause the video if you haven't got it, because I know you guys are too active to have a pen and paper and all. I'm pretty sure of that. So I'll give you 10 seconds. Pause the video, go get your pens and papers and solve this question with me. All right. The question is quite a simple one. The question is this: 5,000 joules of work is done to carry how much charge between 2 points having potential difference of 100 volts? Options: 50 coulombs, 100 coulombs, 1000 coulombs, or 250 coulombs. Quite an easy question. Okay, unfortunately, there's no space for me to write. I hope you didn't see it. All right, anyways, so let's try to solve this, guys. First of all, the work done is given as 5,000 joules. They've also given you the potential difference as 100 volts. You're asked to find out what is the charge, right? That is what you're asked to do. So yes, people, what is the formula? V is equal to W by Q. V is given as 100. What is that? Work done is 5,000 divided by Q. So what is Q is equal to 5,000 divided by 100, which is nothing but 50 coulomb. Very hard, no? Super hard question. You have never seen this kind of hard question in your life. IAS level question, you know. Bacha. I hope you got this right, people. If you got this wrong, no, just remember these 4 words. SSPS. What is it? You might be wondering. I'll tell you that towards the end. Nah, I'll forget it. So let me tell you that. It's nothing but shame, puppy shame. Such a simple concept. Alright, so anyways, guys, with that said, let's get on to the next one. The next thing that we study in electricity, which is one of the most important things I must add, is Ohm's law. What is Ohm's law and why do you need to study this? So guys, Ohm's law is very simple. Ohm's law states that if I have a conductor and the temperature is kept constant, the potential difference applied across the two ends is directly proportional to the current flowing through the circuit. Or I can also say it as the current flowing through a conductor when the temperature is kept constant again. Everything else remains same. The temperature remains constant. In a conductor, the current flowing through that conductor is directly proportional to the potential difference applied at both the ends or at the ends of the conductor. Now, mathematically, people, we have seen that V is directly proportional to I. So again, guys, if you can look at this GIF, see this, it's just like, as you increase the potential difference, the current starts to flow more. That is what it says. So we can say that V is directly proportional to I. So in order to remove the proportionality sign, I am going to introduce a brand new concept called as resistance. So the formula then becomes V is equal to I into R. And what is R here? R is nothing but my resistance. And this is introduced in order to remove the proportionality sign. So in place of that proportionality sign, I'm introducing this constant called as R. And R is nothing but the resistance of a conductor. So ideally, the next question is, sir, what is resistance? Now people, watch the video. But before that, let me explain what is resistance in a simpler manner. Resistance is nothing but the obstruction offered to the flow of charge. What do I mean by that? Look at this beautiful, cute little GIF. Your voltage is trying to push the current, the charges from one end to the other. But what is the other person doing over here? What is the other person, the one with the ohm sign on him? What is he trying to do? He is trying to, he's trying to like crush him so that it does not get through. This is what happens in real world also, guys. Resistance is nothing but the obstruction offered to the flow of charge. When charge is trying to flow from one end to another, the obstruction, the kind of stop that you're doing, all the traffic lights that you have, that is what is resistance. It's basically trying to stop the flow of charge. That is what is called as resistance. And the SI unit of resistance is nothing but ohms. All right, and it is written as omega. All right, this is nothing but ohms written as omega. Got it, people? So what is the resistance? It is nothing but the obstruction offered to the flow of charge. That's it. All right, the flow of electrons. Now here's the thing, guys. There are several factors upon which resistance depends on. What are those factors, you may ask? The first factor that resistance depends on is the length of the conductor. It is directly proportional to the length of the conductor. The more is the length, more is the resistance. The second factor that it depends on is the area of cross section. The more the area of cross section, the lesser the resistance. In other words, area of cross section and resistance are indirectly proportional to each other or inversely proportional to each other. And thirdly, but definitely not the least, is the temperature of the conductor. As the temperature increases, the resistance will also increase. All right. So mathematically, people, I can write it as R, which is nothing but resistance, is directly proportional to L. R is directly proportional to 1 by A because it is indirectly proportional to, indirectly proportional to the area of cross section. And also, guys, R is directly proportional to the temperature, which is nothing but T. So I can write this as R is equal to, or R is directly proportional to L by A. Simple. I'm just, I'm just combining the two and I'm writing it as what? R is directly proportional to L by A. Now what I'm going to do is I am going to introduce another proportionality constant to remove this proportionality sign called as resistivity. What is resistivity? Let me tell you that also. Relax, calm down, I'm here. No, resistivity. Resistivity is nothing but the resistance offered by a material of unit length and unit cross section. If I take 1 centimeter length and 1 centimeter square cross sectional area, what is the resistance offered by that particular material? That is what is resistivity. And hear me out, guys. Resistivity is the property of the material. Every single material has its own resistivity. It's not that every single material has the same resistivity. When the resistivity changes, resistance also changes. As the resistivity increases, resistance also will increase. So my formula then becomes R is equal to rho L by A. And this, my friends, is a very, very important formula in order to calculate resistance when the length of the conductor is given, when the area of cross section is given, and the resistivity of a conductor is also given. All right. And if you want to find out the resistivity, what will the formula become? Just again, simple arithmetics. So resistivity is equal to what? R into A by L will be the formula. That's all. Just crisscross, cross section, not cross section, cross multiply, simple arithmetics. You'll get the answer. Alright, guys. So that is the formula for resistivity, and that is the formula for resistance. Alright, guys. So yeah, people, this is my formula. Again, resistivity is nothing but the property of the material. So it is nothing but rho. It is represented as rho, and the SI unit of resistivity is 1 by ohm, because again resistivity is indirectly proportional to resistance. So it is it's directly proportional to resistance. Sorry about that. Sorry about that, guys. Yeah, sorry about that. It is directly proportional to resistance. So again, as the resistivity increases, the resistance also will increase. The SI unit of resistivity is nothing but ohm inverse or mho. Just the inverse of that. Like you're writing it like a palindrome, you write it. What is it called? It's inverse it, laterally inverted. So instead of OHM, here it is MH. Mho is the SI unit of resistivity. Alright, people. So with that said, guys, let's do another question based on resistance itself. So here is your question. Voila, people. Super duper question. Easy. Try it out. Let me know in the chat box and let me know in the comment section also. The question is this. Resistance of an electric iron is 50 ohms. 4.2 ampere current flows through the resistance. Find the voltage between the 2 points. What a difficult question, no? So once again, guys, I'll give you 5 seconds. Try the question by yourself. Don't just depend on me. But in the meantime, I'll try to solve it. So resistance is given as 50 ohms. They have also given you the current as 4.2 amperes. How will you find out the voltage? Quite simple, guys. V is equal to I into R. V is what they are asking you. So V is equal to what? 4.2 into 50, which if you multiply 520, 5 to 10, so it will be 210 volts. Simple. That's all, guys. Two step, and you're done. 210 volts will be the answer. That's it, guys. If you've gotten the answer, congratulations. If you did not get the answer, still congratulations, but in a sarcastic manner. Anyways, moving on to the next concept, guys. The next thing that we talked about was series, resistance in series and parallel. So here's the thing, people. Resistor is a device that is that is connected in a circuit in order to produce or in order to control the current and voltage, in order to regulate the current and voltage. That is the whole point of having a resistance in a circuit. Now there are two types. There are two ways that you can connect resistors. One is series connection and the other is parallel connection. So in series, what you do is that you connect the resistors one after the other. Series, like one after the other. Like session, like in your what is that, when you're watching series, like your TV shows also, season 1, season 2, season 3, it'll go on like that. No, the exact same way, one after the other. It's not like season 3 will come first and then season 2 will come. No, it's not like that. 1, 2, 3. No, in the exact same way, one after the other is nothing but your series connection. So R1, R2, R3 all connected one after the other. Now here, if you look at it very carefully, the current that is flowing through this is going to be the same. So the same current passes through R1, the same current passes through R2, and the same current passes through R3 as well. But the one thing that is different is the voltage. The voltage across R1 will be different from the voltage across R2. The voltage across R2 will be different from voltage across R3. So here's the thing, guys. In series connection, the current remains constant, but the voltage is distributed. And that voltage, when you sum up all that voltage, V1 plus V2 plus V3, that will be the voltage that is provided by the battery. Alright, but current on the other hand remains constant. And if you want to find out the equivalent resistance, that is, I want to find out what is the total resistance, all I have to do is find the sum of the resistors. Sum of the individual resistors will give me the equivalent resistance. What do I mean by that? So what if I add all these three resistors, that is R equivalent is equal to R1 plus R2 plus R3. Then I can simplify my circuit as one single resistor, which represents the combination of all the three resistors that I have. So rather than writing it separately, rather than drawing it separately, I can combine them as one and write them as one single resistor, which is equivalent, which is equal to the individual resistor that I already had. So how do you find that out? It is nothing but the sum of the resistors. So R1 plus R2 plus R3 is the formula to find that out. Alright, guys. So when you talk about parallel, it's a little different. In parallel, guys, it's one, it's along the side of another, like one after another. It's like that in the sense, not like alongside of another. You can see this, that both the ends of the resistors are connected in parallel connection. And here the thing is this, guys, the current gets distributed. If you look at the current, if the current is flowing through this, current will get distributed as I1 and this will become as I2, but the voltage will remain constant. The voltage across R1 and R2 will be the same, but then the current gets distributed in the case of parallel connection. And once again, if you want to find out the equivalent resistance, that is to combine both of them and make them as one. The formula is this, guys. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on and so forth. It's basically the reciprocal, the sum of reciprocal of the individual resistors. So one thing you must remember is this, guys. In series connection, you will if you want to increase the resistance, you would connect them in series, and if you want to decrease the resistance, you would connect them in parallel. All right, I hope you understand this, guys. If you still have any doubts, make sure that you check out the video first. All right, trust me, guys, everything will be super duper clear once you do it. All right, and once again, people, if you want to find out what is the once you find out the equivalent resistance, so the formula, guys, is 1 by R equivalent. So always remember to reciprocate it in order to find the R equivalent value. So once you find out the value, reciprocate it one more time in order to get the true equivalent resistance. So the formula becomes R. If for n number of resistors, it is R equivalent is equal to R by n. That is the individual resistors divided by the number of resistors, which is nothing but n. All right. I know. It's too much, a little too much. Anyways, guys, with that said, let us do another question. The question is this on your screens, people. We have 4 resistors A, B, C, and D, and the resistance are 4 ohms, 8 ohms, 12 ohms, and 24 ohms respectively. Find the lowest resistance which can be obtained by combining these 4 resistors, and find the highest resistance which can be obtained by combining these 4 resistors. Again, guys, I just told us, if you want the lowest resistance, what would you do? You would connect them in parallel. So how do you find out parallel equivalence? R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So it will become what? 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. So what is the LCM? 24 is the LCM, I believe. So you can write it as 4 into 6, 8 into 3, 12 into 2. So what will you get? You'll get a 6 plus 3 plus 2 plus 1. Guys, again, do it with me, all right? I'm just doing it because we have a lot more to do and I'm going a little slow. But please solve the questions with me, all right? So now, how much is that? 6 plus 3, 9, 9 plus 2, 10, 11, 12. So 12 by 24, which if you divide, you have to reciprocate this because it's 1 by R equivalent. So R equivalent is equal to 24 by 12, which is nothing but what? 2 ohms. Simple. This is when you connect them in parallel. You're going to get the least amount of resistance. When you want the highest amount of resistance, what would you do? You would connect them in series. And what would be the equivalent resistance over there? R equivalent would be what? 4 plus 8 plus 12 plus 24, which is equal to what? 20, 24 plus 24, that's 48 ohms. So the answer, quite simple, is option number A. I hope you got this, guys. Again, if you want more time, please pause the video where I started the question and try to solve it out by yourself and try to compare if you got the right answer or not. All right, because I'm going a little too fast because we have a lot more to do. That's why I had to go a little fast on that. All right. So anyways, guys, moving on to the next thing that we studied in this chapter was heating effect of electric current. What is heating effect of electric current? See, guys, when current is flowing through a conductor, because of resistance, some amount of electrical energy is lost. So what will happen is that the electrons will collide with other electrons or other atoms. They lose some energy. This loss of energy is in the form of heat. So what is heating effect of electric current is nothing but when current is flowing through a conductor, the heat generated because of the flow of current is what is heating effect of electric current. Now there are few devices that you need this heating effect of electric current. For example, if you talk about iron box, room heater, you need this to happen. But this in most cases is not ideal, but in some cases you need this to happen. So how do you calculate, how do you find out the amount of or the heating effect of electric current? That is, how much amount of heat energy is produced in a conductor. So the formula is quite simple, people. See, guys, the work done by the battery is equal to the energy gained by the charges, because the more the work done by the battery, the more the energy is gained by the charges, and they'll flow from one end to the other. And if they are flowing, they will also lose some energy. That means that the energy losses heat is also the same. So I can write it as E, which is nothing but the energy is equal to work done. And the formula for work done, if you remember, V is equal to what? W by Q. So from this we can get that W is equal to what? V into Q. So I can write this as E, because why? The work done by the battery is equal to the energy gained by the charges, because the work is done on the charges and the charges are gaining energy, and that's why they're moving from one end to the other. So simple. So I can write it as E is equal to W, which is equal to V into Q. Now what is V, people? Or what is Q? Let's start with Q. What is Q? Now, what I'm going to do is, to simplify this equation, I'm going to divide this Q. Q is nothing but charge. I'm going to divide it by T and multiply it with T. So what will you get? Q by T into T. Again, the value does not change because T gets cancelled, right? So value does not change. What is Q by T now? From the first concept that we studied, that is nothing but current. So I can write the formula as E is equal to V into I into T, which I can also write as H is equal to V into I into T, because it is nothing but heat energy itself, because the amount of energy gained by the charge is equal to the energy lost by the heat, as heat. So I can also write as H is equal to V into I into T. Now, in place of V, people, in place of V, if I substitute IR from Ohm's law, what will this equation become? It will become I square RT. This, my friends, is called as Joule's law of heating, where heat energy produced is proportional to the, or is equal to the square of the current passing through the conductor. It is equal to the resistance of the conductor, and it is also equal to the time for which the current flows through the conductor. Alright, and this, my friends, is your Joule's law of heating. Alright, this is what is called as Joule's law of heating. Alright, and yes guys, based on that, we'll do another question. Here it is. Two bulbs have current have rating 100 watts and 220 volts and 60 watts and 220 volts respectively. Which has a greater resistance? Options: 60 watts and 200 volts. Is it 100 watts and 220 volts? Is it that both of them have the same resistance, or can't say? What do you think is the right answer, guys? It's quite an easy one. Actually, you don't even have to calculate it. It's a direct equation, direct answer. How do you do this? Now, we know that what we have just seen, that heat energy is what it is. We'll talk about in terms of resistance, all right? So we know that power, which is nothing but P, 100 watts, is nothing but power. So power is equal to V into I. This is the basic formula. Here, if you look at it carefully, guys, the voltage is constant. So what I'm going to do is, I am going to, in place of I'll write as what? I is equal to V by R from Ohm's law. So I can write it as what? V square by R. Now for both of them, the voltage is same. It's 220 by 220 itself. So I can say that because the voltage is same, I can say that power is indirectly proportional to resistance. Because why? Voltage is same. So I can say that power is indirectly proportional to resistance. So from this, guys, you can see that when power increases, resistance will decrease, or when resistance increases, power will decrease. Now in this case, which has more power? The 100 watt has more power, 60 watt bulb has less power. So which has more resistance then? The 60 watt bulb. Because why? Power is indirectly proportional to resistance when the voltage is kept constant, and in this case voltage is constant, so you can come to that conclusion. Alright guys, so that said, people, one more question. Here is another one. We are almost done. I know that it's been a long journey, and I am also feeling that heat, but still guys, let's do it. An electric iron connected across a voltage of 220 volts consumes energy at a rate of 100 watts when heating is at a maximum rate, 400 watt when heating is at a minimum rate. I know. What a way to read the question. Let me repeat that question. An electric iron is connected across a voltage of 220 volts, consumes energy at a rate of 100 watts when heating is at a maximum, and consumes 400 watts when heating is at a minimum rate. What is the values of current when heating is at maximum and when heating is at minimum? Options: 2.5 amperes and 1.5 amperes, 4.55 amperes and 1.82 amperes, 4.55 amperes and 2.25 amperes, and 3.45 amperes and 1.82 amperes. Let's try to do this. Alright, so first of all guys, what is given? Voltage is given as 220 volts. The power when it's high is 1000 watts. The power when it is low is 400 watts. You'll also find out what is the when the current is when the power is maximum, what is the when the heating effect is maximum, what is the current flowing through it? So how do you calculate that, people? Once again, P1 is equal to P is equal to V into I. So how do you find out the current? Quite simple. 1000 is equal to 220 into I. So what will be my equation then? So 1000 divided by 220 is equal to I, which is nothing but 0, 0 gets cancelled. 2, 11, 2, 5, 10, 0, 11, 4, 44. So that will be around 4 point something. 4 point, 4 point what? 4.55. all right, let's just take it like, I really don't want to do the fractions and all that. So yeah, you get the point, people. I did it at least so far. No, be happy about that. Anyways, 4.55 amperes is what you get. When the heating is at minimum, what is the current flowing through? So once again, how do you do it? P2 is equal to V into I. So once again, or we can take it as I2 and this is I1. So this is what, so P2 is what, 400 is equal to 220 into I2. So what is I2 equal to? 400 divided by 220, 0 gets cancelled, 2 to 11, 2 to 4, 0. So 11, 1.8 something you're going to get, 1.8. That's how it is. All right. So the answer to this question is 1.82 amperes. That's how people. So the current, when it is maximum, is 4.55 amperes, and the current is minimum, or when the heating effect is minimum, the current is 1.82 amperes. All right. So with that said, people, moving on to the pretty much the last concept, which is nothing but electrical energy. So guys, electrical energy is nothing but is what? Electrical energy is what? The energy. It is a form of energy. Electrical energy is nothing but the energy that is generated due to the flow of current or the flow of charges. That is what is electrical energy. So electrical energy consumed by a certain electronic device is equal to power into time. Because right guys, if you remember, power is what? Power is, rate of doing work or rate of change of energy is what is power. That is what is power. Now, so what I'm going to do is I'm just rearranging the equation. So I'll get it as what? Electrical energy consumed is equal to power into time. But power is what? Power is nothing but what? V into I. Because we have just seen that power is nothing but volt into current. So I can write it as V into I into T. This, my friends, is one of the basic formulas that we've already seen. We've already, when we talked about Joule's law of heating, if you remember, we have already gone through that. So yes, guys, energy is equal to power into time, which is nothing but V into I into T. And if you want to find out the cost of electrical energy, because yes, guys, based on this itself, they calculate how much electricity bill you're paying every single month. So how do you calculate the cost? Quite simple. So whatever energy consumption you get, convert that to kilowatt hour. Convert that to kilowatt hour. So whatever is the total kilowatt hour, whatever is the energy consumed in terms of kilowatt hour, multiply that with the cost of the cost of electricity per kilowatt hour, you will be able to find out what is the cost, or what is the what is the charge that you're getting charged for per month energy consumption. Now what do I mean by that is, we'll do that with a very simple question and we'll understand it in a very detailed manner. So this is the question, guys. It's a very detailed question, requires a little bit of calculation, but yes guys, I want you to do it. This question is very important, so try this question out. The question is this, guys: a house has 3 tube lights, 2 fans and television. Each tube light draws 40 watts, the fan draws 80 watts and the television draws 60 watts on an average. All the tube lights are kept on for 5 hours, 2 fans are for 2 hours, 12 hours, and the television for 5 hours a day. Find the cost of electric energy used in 30 days if the rate of rate is 3 rupees per kilowatt hour. I'm sorry guys, I'm losing my voice. My voice is not that great. That's why I'm not able to talk that long. So nonetheless, let's take a look at the options as well. The options are that rupees 285.7, rupees 400, rupees 350.8, or rupees 253. Oh my god, I went all the way to the last page. Amazing. This is called a skill. This is skill. You will not find the skill anywhere. All right, so how do you do this question, guys? It's actually quite simple. So first of all, find out the energy consumption by the tube light, by the fan, and by the television. Now, first of all, guys, just by looking at this question, if this was the case in my house, my mom would have been like, the first question that my mom would have asked is, what, Diwali is going on or what? Turning on light for 4 hours in the 5 hours in the morning, yeah, that's all. Dead only. Anyways, so first of all, guys, find out the energy consumed by the television, by the tube light, and the fan. So by the tube light, there are 3 tube lights which consumes 40 watt of power. Again, energy is what? Energy is power into time. Energy is equal to power into time. Power is given as 40 watt, and time taken is what? It is on for 5 hours a day. So this is the thing that you're going to get. So how much is that? 5, 4, 20, 236. So 600 watt hour. 600 watt hour is what you're going to get. Now, find out the energy consumed by the fan. What is the energy consumed with the fan? Once again, there are two fans which has a power rating of 80 watts, and it is on for about 12 hours. So how much is that, guys? That is 24 into 80. That's I know, I'm just do the calculation. It'll be around 1920 because I've already done it. So I'm just gonna write it directly over here. So here it is 1920 watt hour. Now to find out the energy consumed by the TV. So once again, there's only one TV and it has a power of 60 watts and it is on for about what, 5 hours a day. So 5, 6, 30. So that's 300 watt hour. First of all, let's find out the total power now. So total energy consumed. The total energy consumed is 600 plus 300 plus 1920, which is nothing but 900 plus 1920, which you will get it as around 2820 watt hour. Again, guys, I've already done the calculation. That's why I'm writing it directly. All right. I am no math genius that I'm doing mental calculation. Don't think that great of me. All right. So yeah, I got it as 2820 watt hour. This is in terms of watt hour. First of all, guys, convert it to kilowatt hour. So what do you get? Divide this by 1000. You'll get it as how much? You'll get it as 2.82 kilowatt hour. All right, you'll get it as 2.82 kilowatt hour. Now, people, this is the energy consumed per day. Per day is the energy consumed. They are asking you for 30 days then. So what is the total energy consumed at the end of 30 days? Or let's calculate the cost now. So what is the cost? Cost is equal to total energy consumed per day into 30 days into 3 rupees, because the cost of each kilowatt hour is 3 rupees. So if you multiply this, you will get the answer as something around 258 point something, if I'm not wrong. 53.8. So you'll get it as 253.80. I know, right? I'm so good at math. Anyways, guys, so that's how you do it, as simple as that. So once you find out, again, guys, you can either do it this way or you can initially multiply this for both and find out the total energy consumed in the whole month. Then multiply it with the cost per unit charge. Get the answer. Simple as that. All right, guys. And that is it, guys. That is it for today. I hope you enjoyed the session. Do not forget to like, share, and subscribe. And if you would want a detailed, analysis, a detailed, in-depth learning and understanding of every single concept in, be it physics, chemistry, math, bio, social science, or English, you can enroll into the Vedantu's Pro Subscription courses and avail yourself a chance to be and to study with the best. You get 100% knowledge and 100% marks if and only if you listen to what we say. It's not just that you enroll into the class and it's done. No, if you listen to us, but for sure, guys, we can guarantee you that you would have some improvement in your score with the help of Vedantu's improvement promise. I'll tell you what is Vedantu's improvement promise towards the end, but before that, guys, let me tell you about the courses. First of all, guys, every single course that you subscribe to have unlimited live sessions. There is no limit as to how many sessions you can take in a day. You have amazing quizzes, because obviously I know that you guys love quizzes. Most of you guys attend sessions only for the quizzes. So yeah, awesome for that. But yes, guys, we would be having some amazing quizzes in every single session, and these quizzes will give you an opportunity to understand what are your strengths and weaknesses, and understand how good you are and what are the things that you should do in a particular topic in order to make yourself better. And yes, the replays are also available, and the replays are also such a way that you can take the replay at any point of time and also take the quizzes while watching the replay and check out the leaderboard. How cool is that, people? With that, I know that notes are important. We know that notes are important, so you can download all the premium content. Every single handwritten note is downloadable. And to top it all off, guys, every session will not just have the master teacher, but to accompany you people, to ensure that all of your doubts are cleared, all of your queries are cleared with the master teacher. We will also have the class teacher, the classy teacher. The class teacher will ensure that every single doubt of yours is cleared inside the class itself without any questions. Like, whatever doubts you have, unlimited doubt solving pertaining to that particular topic. For example, if I'm teaching Ohm's law pertaining to that particular topic, all of your doubts would be cleared inside the class itself. And yes, tests and assignments already are there. There are some amazing tests and assignments which will definitely blow your mind off into the ground. So you head off into the atmosphere. And yes, some amazing micro courses also. KVPY preparations, NTSC preparations, your Olympiad preparations, your stress relief sessions, tons and tons of activities are also all for free, all in the same package. So it's a one-stop shop for everything that you need about your educational needs. So yes guys, how do you enroll into the courses is the next question. Quite simple guys. So you can see this is one of the videos that came out recently for electricity itself. I believe this is electrical power. This was one of the sessions that came out very recently, the previous one, that is. So yeah, make sure you check that out. The link is right there. So what you do is guys, basically click on this link that is there, that is subscribe to Vedantu Pro right now. You can check out all the series that is going on, all the playlists that you can check over here. You can check it over here. So click on subscribe to Vedantu Pro right now. It'll directly take you to this page where you can check out all the things that you need. So right now you can go to edit, check out for which grade and which syllabus do you guys follow in school, Maharashtra, be it ICSE, any NEET, JEE, CBSE, whatever course you're in. Click on that guys, and this is going to appear in front of you guys. You can check out all the details over here. So here's the thing guys, there are 3 different types of courses that is offered by Vedantu: Vedantu Lite, Vedantu Classic, and Vedantu Pro. All these 3 have different advantages, different disadvantages, different features among them. For example, Vedantu Lite has everything that you need. You have live classes. You need whatever you need, whatever the basic features are, that is definitely going to be there. Everything that you need, like live sessions, assignments, tests, test series, doubt solving inside the class. But the only problem is that there will be no doubt solving outside the session. In Vedantu Classic, that is covered. You have Vedantu doubt solving inside the class and outside the class with the help of the Vedantu app. Vedantu Pro Plus has all of these, and you also get the personal mentor, a personal touch, a personal source, a single source of contact who will ensure that all of your academic doubts are clear, non-academic doubts are clear. He'll ensure that you are going on the right track. Alright. So again guys, the price are different. You have 1 month subscription and the year-long subscription as well. So 1 month subscription for Vedantu Lite is 3,060 rupees. Now I know you must be wondering, sir, 3,000 rupees is a lot of money. But think about it guys. 3,000 rupees. Let's say it is 3,000 rupees. You have physics, chemistry, math, bio, social science, all 6 subjects. So how much is that guys? That's about 500 rupees per subject. What more value for money do you need? With this, you also get KVP preparations, your NTSC preparations. I mean, outside also when you go for tuitions, you pay about 500 rupees per subject, 500, 600 rupees per subject. Here, all of that is covered as single. And best part, you don't have to go anywhere. Sit at home in the comfort of your own chair and enjoy. That's all, people. And yes guys, the year-long program for that is 29,699 rupees. Again, the whole year program, that's 12-month complete course, complete syllabus coverage is done over there. And again, year-long program for Classic is about 39,149, and the monthly program is about 3,870, the monthly subscription. For Vedantu Pro Plus, that's about 5,580 rupees per month, and year-long program is 50,399 rupees. All right. Again, guys, you can check out all the best teachers who's going to be available for you guys, the class timings that you need, the testimonies, the results that we've achieved in the recent Olympiads, everything that you need, all the frequently asked questions, all of that can be seen over here, all in that one particular link. That's all, guys. So yeah, guys, that's all for today. I know that and also guys, by the way, people, to top it all off, like a cherry on top of all this ice cream that I just served you, we also have the Vedantu's Improvement Promise. What is Vedantu's Improvement Promise? Vedantu's Improvement Promise says that if you enroll into the year-long program and you're not seeing any improvement in your score, given that you're attending the sessions and you're still not seeing any improvement in your score, you can claim for your complete money back. Trust me, no institute in the world gives you that guarantee that you can get your money back if you don't see any improvement in your score. At Vedantu, we are giving you that guarantee also. What more do you need, guys? All you have to do is click on the link, enroll into the courses. So that's it, guys. That's all for today. Thank you for joining. Catch you guys in the next one with a brand new chapter. Oh, by the way, we'll also be coming live for quizzes. So make sure that you subscribe to the channel as well, guys. Thank you for joining. Catch you guys in the next one. This is Anup signing off the day. Have a great evening ahead. See you guys soon. Bye-bye. Have a great week. Ta-ta. Adios. Ciao. Bye-bye.